This is the third video in the Study Well series of Newton's Laws of Motion videos. So hopefully by now you've had a chance to look at the first two videos on Newton's first and second laws. Now, by way of reminder, I will just post Newton's laws here, and I'll give the third Newton's law in addition this time, as we're going to be using Newton's third law in this question. So this question is taken from a past paper. It's from the modular series and it's from 2017. So it's M1, it's question 5 on the M1 modular paper from summer 2017. So we've got a vertical light rod, PQ, and it has a particle of mass 0.5 kilograms attached to it at P and a particle of mass 0.75 kilograms attached to it at Q, and it forms a system as we can see there. The system is accelerated vertically upwards by a vertical force of magnitude 15 newtons applied to the particle at Q, and for 6 marks we're asked to find the thrust in the rod. Now, Newton's first law says that a body will stay at rest or will move with constant velocity unless acted upon by a resultant force. Now, we've got a bit of a more complicated situation here because we've got multiple forces working and there's two particles. Second law says that the force required to accelerate a particle is equal to the product of the particle's mass and its acceleration. So F equals ma. Because we have acceleration in this system, we will be using that at some point, but we're also using Newton's third law that says for every action there is an equal and opposite reaction, and we're using Newton's third law here because the two particles that we see in this system are connected, and it just means that when they're in contact, if body A, or in this case Q, exerts a force, which is thrust, on a particle P, then particle P exerts the same force on Q, and it's equal in magnitude and acts in the opposite direction. So if we have Q, say, thrusting, sort of like passing the force through the connection, let's call that thrust, I'm going to label that as T, then because of this connection, we will have the same force, which is equal and opposite in magnitude, so that will also be T. Now, as with most questions, or exam questions or practice questions that have connected particles, you inevitably do something with simultaneous equations. And what you do is you treat the two particles separately. So I'm going to look at Q first of all. So suppose this is particle Q. Now what we've got is this force of 15 newtons acting in the upwards direction. And we've got two forces acting in the downwards direction. One of them being weight, which will be mg, and the other one, which we can see as we've labelled up there on the diagram, will be thrust, which we're calling T. And we can do a similar diagram for P. So with P, we've got the thrust acting upwards. And if we're treating them as isolated particles with their own sort of systems, then the only two forces acting on P is the thrust upwards and its weight downwards. So what I'm going to do here is change that M, because they have different masses, to 0.75. And the weight force acting on P is 0.5 G. Now, the simultaneous equations are going to come from finding the equation of motion for each of these particles. Yeah, so that you've got these the T is in common. We know that G is a known constant. And we use Newton's second law to derive the equation of motion for each of the particles separately. So Newton's second law is saying that F equals ma. So the resultant force for each particle is that particle's mass times by acceleration. So for Q, RF equals ma becomes, so resultant force, which would be, so let's do the positive direction being this way, which we're told in the question. So 15 take away 0.75 g take away t equals mass, which is 0.75 times by its acceleration, which we don't actually know at this moment in time. So your positive force and your two negative ones being equal to the mass times the acceleration. And then for particle P, also F equals ma, but this time the positive force is just T, and then your downward force is 0.5 g, so that's weight. So your resultant force is T minus 0.5 g, and that's going to be equal to its mass times acceleration, which is 0.5 a. Okay, right, so you can see here we've got simultaneous equations, 1 and 2. So the idea in this question is to find the thrust. So we need to find the value of t. So what I would suggest doing, first of all, is eliminate t to find your acceleration, and then substitute that back in to find to one of the equations to find the value of t. So how do we do that? I am going to add the two equations together. So the reason I'm doing that is because you can see here there's a minus t and a positive t. If I add them together, I'll eliminate t, and that'll allow me to find a. So add them together, 15 minus 0.75 g. So we would have a minus t, but I'm going to plus t to cancel, and I've got my minus 0.5 g, will give me 1.25 a. So I'm going to use g is equal to 10 in this case. So 15 minus 7.5 minus 5 is equal to 1.25 a. So what is that? 15 minus 7.5 is 7.5. Take off 5 is 2.5. Equals 1.25 a. Giving me an acceleration of 2. Note that if you use g is 9.8, then your acceleration would be 2.2 meters per second squared, of course. And then I'm going to substitute that value of a into the second equation, because it's slightly less complicated than the first one. And using g equals 0.5, g equals 10 again, I'm going to have t minus 5 equals 0.5 times 2. So t minus 5 equals 1, leaving me with a thrust of 6 newtons, or, oh no, there's also t equals 6 newtons. So, for 6 marks in an exam question, it's still relatively simple, but it's the first one we've seen in the Study Well series where we actually use all 3 Newton's laws. We find that the thrust of the connected particles there is 6 newtons. So if you want to find out more about connected particles and the other Newton's laws of motion, then check out studywell.com.